Here are the answers to 1.6 pre-calc. In questions 1 through 8, you're asked to determine whether or not the sequence is arithmetic, geometric, or neither. So looking at number 1, you were asked to do 1 through 21 odd. In question number 1, going from 2 to 7 to 12, 17, 22 to infinity. From 2 to 7, you're adding 5. And you're adding 5, and adding 5, and adding 5. So this one is an arithmetic sequence. Number 3, 13, 13 halves, 13 fourths, and 13 eighths. Whoops. This one is multiplying by 1/2 because 13 over 1 times 1/2 is 13 halves. And then 13 halves times 1/2 is 13 fourths. And that pattern continues. So since we're multiplying by the same number, this one is geometric. And the common ratio is 1/2. For number 5, you have 50, 48, 46, and 44. This one is going down by 2 at every term, so this one is arithmetic. Number 7, you're going from 3 to negative 3 halves, to 3 fourths, to negative 3 eighths, and to 3 sixteenths. This one, it looks like you're multiplying by negative 1/2. 3 over 1 times negative 1 over 2 is negative 3 over 2. And let's check this out. What is negative 3 over 2 times negative 1 over 2? It is positive 3 over 4. And if you keep multiplying by negative 1/2, you get the next term. So this one is geometric, where the common ratio is negative 1/2. The next set of problems, starting with 9, asks you, it says the first term, u sub 1, is given, and the common difference or common ratio is given. These are all geometric. You are asked to find the 6th term and the 2 formulas, recursive and explicit formulas. So we have 3 things we have to tackle. So you're given the first term. These are geometric. Number 9, you're given u sub 1 is 5, that's the first term, and r is 2. So we need let's do a recursive formula. U sub 1, the first term is 5. You always state the initial condition. U sub 1 is 5, and u sub n is the previous term times the r value, which in this case it's given as 2. You're going to use this formula if you want to find the 2nd, the 3rd, the 4th, the 5th, and you could do that. You could just keep multiplying each term by 2 to get to the 6th. But let's look at the other formula, the explicit. It's u sub n, it's the first term, times r, which is 2, to the n minus 1 power. This one is recursive, and this is explicit. Now to find the 6th term, you can plug 6 right here, or you can do it one at a time. I would probably prefer the explicit. So what is 5 times 2 to the 5th? You should get 160 for an answer after you multiply that by 5. So the 6th term And make sure you do order of operations. You do this first and then multiply by 5. Number 11, they give you u sub 1 is 4, and you are given r is 1/4. Okay, so again, we need let's do the recursive formula. It is u sub 1 is 4. State the first term, then u sub n is the previous term, and then times the r value, which is 1/4. And for the explicit u sub n, it's the first term, which is 4, times the r value, 1/4, to the n minus 1 power. And if we're finding the 6th term, you're going to do 4 times 1/4 raised to the 6 minus 1 or 5th power. That is a 1. And the answer for number 11 is 1/256. You could just go 4. One of these 4s is going to cancel. You've got 4 to the 5th power. So if you want to think of it that way, 4 times 1/4, this is to the 5th power. So you're taking 1 and raising it to the 5th power and 4 to the 5th power. One of these 4s could cancel out, you could think of it that way, and this is really 1/4 to the 4th power, that's how you get 1/256. 1 to the 4th power is just 1. Number 13, you are given u sub 1 is 10 and r equals -1/2. The ratio is -1/2. So the recursive formula, you're going to state the first term, which is 10, and to find any term, it's the previous term times the r value, which is -1/2. Now you need to put this in parentheses, otherwise it's going to look like subtracting half. So this is the recursive, and the explicit would be u sub n is equal to, it's the first term, times the r value to the n minus 1 power. So that's the explicit formula. Now if you want to find any term, simply plug that n value in here, so 6 minus 1, which is 5, so the 6th term is found. You want to first of all, this is a 5, so it's 10 times -1/2 to the 5th power. So be careful when you're multiplying and there's a negative. If this happens to be an even power, that's going to turn positive. So when you do this one, you should get, let's do this one on our calculator. So we would have, if you do this correctly on your calculator, it's -0.5. You're going to raise this to the 5th power and then multiply that by 10. And that's your answer, -0.3125. Now change this to hit math and frac and hit enter, and that's your fraction reduced. -5/16. So -5/16 or -0.3125. They're both good answers. Okay, moving along. Question 15 states, it says find the kth partial sum. So k is the number of terms you're going to add together. You're given a geometric sequence, and the common ratio is also given. So they give you the first term, they give you the r value, and they're asking you to add the first 6 terms. So how do we do this? Well, the formula is the sum of the first 6 terms is going to be the first term times 1 minus the ratio to the n power. That's the number of terms you're adding together over 1 minus r. Well, they give you that u sub 1 or a sub 1 are the same thing. they give you the first term is 5, and they give you the R value, and they tell you they want you to add 6 of these terms together with this given pattern. So here is your work. You have a 5 for the first term, half for the ratio. Now how do you do this on a calculator? You could do this first, this 1/2 to the 6th power, and then do 1 minus that answer, multiply that by 5, and divide this all by a half or 0.5. You should get, for this answer, for number 15, I got 9.875. So on a calculator, how does this look? Okay, so we've got 5 times 1 minus, then I'm going to put 0.5 in parentheses, raise this to the 6th power, and then I'm going to end my parentheses. And then I'm going to figure out what that answer is, and then I'm going to divide this answer by 0.5, and that's the answer. Now if I want to see what it looks like as a fraction, I hit that, and I get 315 over 32. So that's another answer, either one, 315 over 32. The next one, number 17, same thing. Number 17. You are going to add up, it says K is 7, U sub 2 is 6, and R is 2. Okay, so in our formula, it's a good question. In our formula, we have to add up terms in a geometric sequence. We have this formula: a sub 1, 1 minus r to the n power over 1 minus r. But I don't see, I know what k is, or n, same thing, k and n are the same. And I know what 2 is my r, but I don't know what the first term is. I know what the second term is, but I know the ratio is 2. So if the first term we don't know, we know the second term is 6, or I should use u sub 1, u sub 2, same thing. And I know the ratio is 2. To get to this next, the a sub 3 or u sub 3 term, I would simply multiply this by 2. I'd get a 12. So to go forward, I multiply by 2, but I want to go backwards, so I'm going to divide by 2. So your first term is 3. So a sub 1 or u sub 1 is 3. So what do? You're going to plug a 3 in here. 3 times 1 minus 2, I'm adding up 7 terms over 1 minus 2. And that's the sum. And you should get, for number 17, the answer is 381. So try that. Okay. Number 19 is a proof. It's asking you to show that the given sequence is geometric. So what you're going to do on this problem is you're going to generate some terms. I have it right here. Here's the expression that they give you. So if I say let n equal 1, if I plug a 1 in here, I get the first term is negative 1/2. When I plug a 2 in, I get negative 1/2 squared is 1/4. When I plug a 3, I get negative 1/8. So what you're going to do now is figure out what the common ratio is. This is your first term, this is your second term, and this is your third term. So you take the second term and you divide it by the first term. And what do you get? We're not going to divide, we're going to flip and multiply. So 1/4 divided by negative 1/2 is the same as 1/4 times negative 2, which is negative 1/2. And you do it again. You take the third term and divide it by the second term. And again, we don't divide, we flip and multiply. And you get negative 1/2. So this is a proof. You could do another one. You can plug a 4 in for n, and you'll see that the ratio is -1/2. If I wanted to go this way, I could multiply this by -1/2 and get 1/16 as my next term. So that's a proof. And for 21, they give you 5 to the n plus 2. You do the same thing. Prove that this is geometric. So if you plugged a 1 in here, 1 plus 2 is 3. 5 to the third power is 125. And when you plug a 2 in, 2 plus 2 is 4. 5 to the fourth power is 625. And plug a 3 in. 3 plus 2 is 5. 5 to the fifth power is 3,125. And so forth. So seeing that this is geometric, you would take 625, the second term, divided by the first term, you get 5. And then you do the third term, divided by the second term, and you get 5. And that's your proof. These are constant, so this is geometric, and your common ratio is 5. This ends the first half of section 1.6.